Sanjay, we will take another five minutes time just to get everything is in line. So we'll take another 5 minutes time. It's sharp 7:30, so we'll start at sharp 7:35. We can keep the flyer. Yeah, the Zoom is done with 1,000.
Already 1,000 has
Yes.
joined.
And dear participant, if you have any friends who are not able to join with the Zoom link, so we are run out with the count of 1,000 numbers. So what we recommend is to join with the YouTube live streaming. And please ask all of your friends to join with YouTube live streaming. So we have started the streaming as well. Right, Sanjay? We have already started with the live streaming as well, Sanjay, I believe. Sanjay?
Yes, started.
Right.
Yeah,
Okay.
we are already started with the live stream.
Thank you. Well, good evening, ladies and gentlemen. Please let us have another 5 minutes time. By 7:35, we will start the session. Very good evening, ladies and gentlemen. We warmly welcome all of you through Zoom platform as well as through the YouTube live streaming to the first day of our basic application of design, installation, testing and commissioning of low voltage, electrical and extra low voltage works for construction projects, basically local and international projects. So sometimes people would wonder why we are going to have these CPD programs. And I believe that we all of us know the value of CPD. CPD stands for the continuous professional development. What we know, we might have learned something from the universities, diploma courses, or your own experiences, but there should be some continuous improvement and to have the knowledge of latest developments. At the same time, the current context has to be learned through as well as get the proper exposure and the proper experience through professionals. And for those programs, particularly, we have invited, I should say, the industry giants or the experienced experts who are not just qualified through the papers, who are not having only the theoretical knowledge, but they have a huge and vast exposure to their particular fields. Before moving to the session, ladies and gentlemen, I would like to highlight certain ground rules which we are conducting through these Zoom sessions. And most of you, sometimes we have received a lot of registration, but it has been reached to over 1,000. Therefore, what we can cater through Zoom platform with this context is maximum 1,000. Therefore, for the balance, as well as if somebody is lost his connection due to this power failures or due to the signal failures, he or she can simply join with the live streaming of the YouTube. And at the same time, after this session, you might definitely be uploaded to, you might definitely be connected to a WhatsApp group. So we will put all the recorded YouTube videos for your reference. And this is free of charge, free to share with anybody. Therefore, we recommend as Sri Lankans, we can share with anybody around the world because for the sole purpose of education. And as a country, as a nation, we are struggling right now. We have certain requirements to people to have their knowledge, and maybe sometimes people are struggling with their jobs. People have a risk of losing their job at any time. At the same time, people are seeking some opportunities outside the country. Therefore, to give some helping hands, we have started these CPD programs, and we request and urge you to take the maximum out of these sessions. And particularly to have receive the certificate, we have to strongly look for the attendance. Since it is a virtual platform, we believe that everybody is obeying to the guidelines and the protocols which we are trying to maintain. Attendance to be marked through Zoom chat platforms. You have, right now, you have no access to the chat box, and you are not allowed to use these mics as well. How we conduct the session is generally we have a core session from 7:30, maximum 7:30 to 9 o'clock, 1.5 hours. So in between or just before the Q&A session, which start from 9 o'clock to 9:30 maximum, where you can raise your questions by raising your hands through Zoom platform, or else you can drop a message to your particular WhatsApp group or the organizers themselves. You can send those messages. At the same time, we give some opportunities to shoot your own questions, or you can ask your questions through this Zoom platform as well after the core sessions. Within the core sessions, we are not allowing anybody to use the chat boxes or raise hand. Even the raise hand option is there, but we don't interrupt to the presenter. We have 1 hour or 30 minutes of time for the Q&A session, as well as you can raise your questions even later after these sessions through WhatsApp groups. You can shoot questions, so we will compile them and send across to the resource person, and we'll get the answers and we'll share through all the WhatsApp group as well as email groups. So that's how the session goes technically, and the Q&A session starts around 9 o'clock. At that time, you can raise your questions, and we try to limit it to 30 minutes maximum. And attendance to be marked through the Google form, which is shared randomly. We cannot guarantee that this is the time slot we get this attendance sheet. This is a Google form where you can use it through the Zoom. At the same time, those who subscribe the YouTube channel, you can have the access to the YouTube chat as well. So what we recommend, again, to have a proper connectivity, to have your YouTube channel subscribe, as well as to be alive in this Zoom platform. One final message: if you have lost your connectivity or if you couldn't mark your attendance, what we recommend again, you have to keep at least 2 or 3 screenshots to save or to prove you, if the organizers demand to prove your attendance, to issue the certificate. So that's how the process goes. I'm sure that from next 3 more days, including today, altogether we have 4 days. So we believe everybody will attend, and we highlight that 100% attendance, which is 4 out of 4 sessions, is required to obtain the certificate. With that remark, ladies and gentlemen, thank you very much for being here in a Sunday evening, which we know the value of the session. At the same time, we like to appreciate your presence as well. And with that remark, I would like to introduce today's presenter. Under the main topic, as I mentioned earlier, today's subsector is session 1 of 4, is mainly focused on the main LV, low voltage electrical distribution network of a building, emergency power supply, which is the generators mostly, including ATS, MTS. ATS stands for auto transfer switches, and the MTS for the manual transfer switches, earthing and lightning protection of the buildings. And to introduce today's presenter, Dr. Asanka Rodrigo, sometimes people have that argument, this gentleman is from the University of Moratuwa, and most of the industry people from electrical, low voltage, and even ELV fields know who Dr. Asanka Rodrigo is. Technically, he's from the University of Moratuwa, from Department of Electrical Engineering. But what I respect him the most is he's not just a doctor by the book. So this gentleman has a huge experience, not only designs, not only executions, even the testing, commissioning, and troubleshooting in many fields, not only electrical low voltage, even the lightning protections, and whole area of electrical engineering. So this gentleman is a vast knowledge, and I would like to highly appreciate and honor to have this gentleman on today's session with the Sunday evening, a busy schedule, spending with us. Sir, it's over to you.
Okay, thank you very much, Nalin, for inviting me to deliver this very short the lecture or the CPD for the huge number of participants. I surprised by seeing this number of participants. Okay, that indicates that how much of enthusiasm is there in this field. So that and good evening to everybody. Thank you very much for the participation and showing your interest on getting some knowledge in this electrical installation field. So as Nalin explained, I hope you can see my screen. Is it visible?
Yes, sir. It
hope
looks
my I am also audible without any disturbances.
Yes, all good. Please go ahead.
Okay. So that without taking much time, I will quickly go through the today's topic. Basically, I am covering because you can see this is a vast area, and I am basically covering the LV installation side, the basic what you should know when you are working with the LV installations, and the probably because when you look at this subject area. In undergraduate level, we have 2 full semester subjects in this electrical low voltage application. And when you go to the master's level, we have a lot of subjects. Those who have followed, they already know that how much of area we are covering in this subject. So that the first thing I want to highlight is I'm not going to cover everything, but I'm basically highlighting what are the most important the areas which you should know in this one, and also the basic background, and also now the electrical installation area is changing day by day, and I will show you how it is happening, and even the rules, regulations, and the code practices are also changing. That's why this type of CPD, attending this CPD and getting knowledge on those type of things, what are the current trends, what type of rules and regulations are there, and what are the the new technologies, those type of things are very important for you to upgrade by yourself. So because when you are working in industry, because this sector is the highly changing day by day, so that it's a very dynamic sector. So that because of that, I'm basically covering the LB part, and from the successive other 3 days we'll cover the other areas as well. So that as I said, it's a small sector which within this 1.5 hours time period, which I'm going to introduce to you. So that when we look at this LV applications, the first thing you should understand is, so when we are working in the industry, you cannot do whatever you want. So there are rules and regulations which are applicable for the LV installation. So that when you look at these rules and regulations, what we are following in Sri Lanka is the BS 7671, or in other terms, we call them as a IET wiring regulation. In earlier, it was called as IEE wiring regulation, but now we are calling it as a IET wiring regulation. So that keep in mind, whatever we do in Sri Lanka on LV side, so we have to follow the IET wiring regulation, or what we call as a BS 7671 till we publish our own standard. At the moment, keep in mind, so we don't have our own standard. Normally, our own standards are going with SLS, the standards. But for this area, we are strictly following the one-to-one, the BS 7671 standard. So that is what we are following. So that when you look at this one, actually the latest version is the 2018 version, that is coming as a 18th edition. So that whatever the installation we do after 31st of December or the 1st of January 2019 onward, so that we are bound to follow this IET wiring regulation 18th edition. When you look at this 18th edition, even the currently also, even today, if we start any electrical installation, that should follow the 18th edition. So why I am telling is because there are amendments, so that you can see when you look at this picture. So the original one comes with BS 7671 2018, but the first amendment was done in 2020. So that went as amendment number 1. You can see in here, so there is an additional note saying that incorporate in the amendment number 1. So, but when you look at the latest one, still it is 18th edition, but in the they release a new version in 2022, the January. So that comes with this brown color book. So that is with the incorporation of the amendment number 2. So that here you can see, when you look at this area, that says incorporating the amendment number 1 and 2. So that still it is the 18th edition. You can see no 19, no 20, something like that, because sometimes the people try to interpret as it's the 19th edition or something like that. Still keep in mind that is the 18th edition is the applicable edition with the amendment number 2, 1 and 2 incorporating both of them. So now the common thing you should know that when you look at this IET wiring regulation, that is basically based on the European Commission of Electrotechnical Standard and the International Electrotechnical the Commission IEC standard. So both of them are combined together, and then they came up with the complete comprehensive the regulation. That is what we are following in even in Sri Lanka. When you go to many countries, you will understand that. So this is the base document. So that sometimes the individual countries, they have their own standard, but they took this standard as their base standard, because this is very comprehensive, very old standard. Gradually the built up. And when you look at this one, as I said, it's a very old standard, started in the 80s, 82. Can see even more than 100 years old. The standard actually it started with the reducing the fire risk related to the electric lighting, because at that time the major use of the electricity was for the electric lighting. And when the people were using this electric lighting, they found that there are certain the fire and certain risks are associated. So that in order to prevent those risks, they first came up with this regulation. At that time, the name was, it's the rules and regulation to prevent fire risk arising from electric lighting. So, but gradually, so there were a lot of amendments were happened, so that they released the editions. Those are called as a edition, first edition, second edition, likewise. In the third edition, they changed the name to general rules recommended for wiring and wiring for the supply electric energy. Likewise, then in the 1907, so they used the simple term called wiring rules. So that they released as a fifth edition. And then in 1924, so they came up with a regulation for electric equipment in buildings. So that, because basically this low voltage the wirings are used in building, so that they change the name, still it's the same regulation. So then the major change happened in 1996, where they changed the name to what we call as a regulation for electrical installation. This is the where they introduced new terminology. And this is the time, even in Sri Lanka, we know that when you look at the electricity, so we started our electricity and the regulating the electricity sector from 1950s onward, because even first Electricity Act was passed in 1950s, and then the Electricity Board was established by the basically the removing earlier the government electric department. Government electric department was converted to the Electricity Board, and all the functionalities were taken. In this time, because of the influence from the UK, and we also started to follow this IET wiring regulation, or at that time IEE wiring regulation, or we call as a regulation for electrical installation. This is how it is penetrated to the Sri Lankan market. So then even the Institute of Engineers started to do certain type of training programs and awareness program on this regulation, because that is considered as one of the very good, very comprehensive the regulation which we can follow to when we are doing any electrical installation related activity. So that then the 60th edition came in 1991. So you can see there was a very big gap, because at that time there were not major changes happen in this sector. But in the starting in 1991, they released different versions, and in 2001 they released this the blue color one, and then 2004 the brown color. All of them went as the requirement for electrical installation with that name. So these are the books which were published in earlier. In 2008, this is also one of the turning point. So they released this the 17th edition. At that time, even in Sri Lanka, our Electricity Act was changed. So that our Electricity Act was changed as Act number 20 of 2009. So that at that time, we also incorporated and put this one into the rules and regulations. And because we were following this one without any legal the background, so that by traditionally, so that even the Institute of Engineers Sri Lanka and all of them were promoting this one and practicing, but there were no legal background. And because of that, okay, in the 2008 version, they had an idea of incorporating this as a rule for the Sri Lanka. And then from time to time, because this is the time where there were a lot of the changes were happen, and more power electronic based equipments were introduced to the electrical installation field. And because of that, from time to time, they had to publish several amendments. So that likewise, amendment number 1, amendment number 2 in 2013, amendment number 3, 2015, like that. So that from, you can see, so the every 2 years, they had to publish different revisions. So that then in 2018, they publish a new revision that we call as a new edition, the 18th edition. That is the latest one what we are following. In as I said, they revise it in 2020 as amendment number 1, and now what we are following is amendment number 2, so 2022. So that keep in mind, this is the latest version that you have to follow when you are doing any electrical installation related activity in Sri Lanka. So now, as I said, why we are worried about this one, as I said, because this is already incorporated to our law. Because now normally when you look at the country's law, so the topmost layer of the law is the country's constitution. So that whatever is below the constitution, so that is the constitution is the topmost layer of the legal framework in a country. So that even in Sri Lanka, we have a constitution. Okay, very recently we had an amendment to the constitution as well. So that is the constitution. So then the second layer of the law, what we call as acts. So that even for the electricity sector, as I said, okay, we have an act. So that in 2009, so we publish Electricity Act number 20 of 2009. And then there were the 2 amendments actually. So one in 2013, other one is 2022. So we had the 2 amendments for this Electricity Act, and that is the second layer of legal documents or the legal framework what we have, constitution. After that we have the acts. Then the third layer is what we call as a regulation. So that under the act, so that whoever who is empowered by the act can release certain rules and regulations to safeguard the sector. So that similar rules and regulation was issued in 2016 as the electricity safety quality continuity standard in Sri Lanka. So that in this is a gazetted notification by the line minister. So that minister has the power to the publish this type of regulation under this act. So that is the third level of legal framework. So this very clearly now says that we have to follow until we publish our own standard, we have to follow the British standard. So this is where, so that there is a legal requirement in the country. Now, if you are violating this IET wiring regulation or the BS 7671, you can see it's a BS 7671 at that time 2008 version, or it says the latest. Whatever the IET released a new version, that is applicable, no need any rules or the amendments or anything. So that is the automatically becomes a requirement in Sri Lanka because of this legal requirement. So that keep in mind, it is not just a practice, it's a legal requirement. If you violate, so the whatever the condition given in the IET wiring regulation, that means that you are basically violating a country's law, because it's a law now. So that not like previously, okay, it's like a practice, but now that practice has become a law. So that if you violate a requirement in the BS 7671 in the electrical installation field, so even anybody can take you to a court. So that those who are practicing in this one, keep in mind, now it's a country's law, so that you don't have any other option other than following this requirement. And keep in mind, so that no matter who is the client, no matter who is the funding agency, no matter who is the consultant, so that they cannot bring, okay, this is we are funding this one China, and because of that we follow the Chinese standard. So no one can say, because now it's a legal requirement, so that whatever we do in Sri Lanka, we have to follow the IET wiring regulation. That is the legal requirement. So now when you look at this, the rule and regulation, this IET wiring regulation, so that I cannot apply to everywhere. So there are certain locations where I can apply this regulation, and there is a certain location which are clearly marked as where we cannot apply this regulation. So where we can apply, so that you can see it need to be applied for the residential buildings, commercial building, public installations, the industrial premises, any construction site, exhibition, temporary building, highway, or whatever. If you are working with less than 1000 volts AC or 1500 volts DC, so we have to follow this rules and regulation. But also it says, so this regulation does not apply to the suppliers work. Now, for example, if you look at the supplier in Sri Lanka, the suppliers are the CB and LECO. So that whatever things they do, their poles and the LV distribution line, because they have the separate code. So because of that, so this regulation does not apply to those type of installation. If that is belongs to the supplier, this you cannot apply because they have different the codes and the rules and regulation. And the railway, rolling and the signaling equipment, aircraft, even though the voltages are less than 1000 volts AC or 1500 volts DC, you cannot apply this regulation. So now I hope you are clear that, so that there is a regulation, it's a law. Now you have to apply if you are doing any electrical related activity which is less than 1000 volts AC or 1500 volts DC. Those are what we call as a low voltage. So then we have to follow this BS 7671 in Sri Lanka, and many countries are following the same standard, or as I said, even they have their own standard, but it's one-to-one taken from the BS standard. So that is the basic background. And as a designer or as a people who are working in this industry, so because this regulation is provided basically to provide the safety related to the electrical sector. So that we have to, anyway, we know that I think most of you have already got an electric shock due to whatever reason, but basically we know that how painful that is, because this is very dangerous. Now, if you are working in civil industry or the mechanical sector, even if there is a crack in the building, you can see it. But in electrical field, the problem is you don't know what current flowing to the cable, what voltage that is operating. You cannot smell it, you cannot see it. So that there is a huge danger. So that because of that, we have to prevent the person's livestock and the other properties against the danger related to the electricity, because it's a very dangerous thing. So that you already know that if something goes wrong, even there can be a electric shock, or person can get the death, and even the fire can occur, and even the property can damage. Okay, many things can happen. Even when you look at the newspapers, you may have heard about. So even if there is a fire, so they say the root cause is the electrical related activity or certain hotspots or something like that. So that because of that, we have to always keep in mind this is a risky area. And because of that, you need to have a very strict rules and regulation. So to prevent people and the livestock and the other type of property, our equipment, all of them against electric shock or the excessive temperature or arcing burning, there can be under voltage or low voltage. Those different type of disturbances can happen. There can be electrical the equipment or rotating machines which can create certain type of abnormalities, and that can damage, injure people. Likewise, a lot of things can happen. So that's why we have to very carefully handle this one, you cannot do whatever you want. So now, when you are working in this low voltage field, so that as I said, we have to work very carefully and we have to act according to the rules and regulations given. So that because of that, I'll first introduce. So what are the how we can classify the LV distribution systems. So as per the standard. So that as per the standard, so the standard follows the international what we call as a 2-letter code to represent the electrical distribution system. That's a standardized way of the categorizing the distribution system. So as per this one, we look at how we earth the source side and how we earth the installation side. So that basically the categorization depends on the earthing criteria. So then one can ask, okay, why we are worried about the earthing? Because now obviously, as I said, there is a risk. So that if something goes wrong, so that can create abnormal current and that can create many other hazards. So that because of that, if you have any abnormal current, you have to send it to a safer place. And also when you are working with electricity, now, as I said, we are talking about the 1000 volts AC, 1500 volt DC. So that you have to measure it. And then when you are measuring, you need to have a reference point. So that for those two reasons, we need to have a proper earthing arrangement. So that we look at the earthing arrangement of the source and the earthing arrangement of the installation. So that when you look at the source, we have two options. One is we can do the solid earthing. Other one is we can keep the neutral point isolated way. So that those are internationally we name as the solid earthing. In Latin word that called as a tierra, and the isolated earth we call a isolated neutral point we call as a I to represent the source. So that source side we have two options. One is where we can earth the neutral point, or we can keep the isolated neutral point. Then the installation side, we look at the exposed conductive part. If you look at any electrical appliances, so that you can get certain metal part, outer metal part. So those are conductive part, but anybody can touch those metal part. Now, if you look at even a rice cooker, so the outer body of the rice cooker is metal, but they are not carrying current, but anybody can touch it anytime. But what will happen is if there is any leakage or anything, so that the voltage there can be current flow through those metal bodies. Those are what we call as a exposed. Now exposed to the outside, exposed, they are conductive. They can conduct current. Those are exposed conductive part. So we look at how we have to earth those exposed conductive part. So that we can have one option is we can have a separator, separate to the source. So that again we represent as a T. Other one is we call as a N. That is, we are connecting exposed conductive parts to the source, the neutral point, because the source is already earth. And because of that, we can connect all our exposed conductive parts to the source neutral point. That we indicate as N. Those are standard terms, so that internationally accepted way of representing how we do the earthing for the source side and the installation side. Now, if you look at the overall, now we have two options in the source side, two options in the installation side. Overall combinations are, you can see I can have a T and T, and I can have a T and N, and I can have a I and T, but you can see I have not marked I and N, because I and N is not fulfilling our earthing requirement, because our source is isolated and connecting exposed conductive part to an isolated neutral point will not fulfill any of our requirement. So that as per the standard, as per the BS 7671, they are not defining I in earthing arrangement. So that altogether, what we have is, we have three different type of earthing arrangement, TT, TN, and IT. So the TN we subdivide into three categories. TNC, TNS, and TNCS. I'll quickly go through them. So now when you look at the first type of earthing arrangement, we call as a TT. So the TT, sometimes you may also heard about this one. That is defined as, you can see, one point of source, the directly earth. Okay, you can see I have highlighted few points in red color. So and also I have underlined one thing. So the one point. So that in a TT system, you can have different the sources. So for example, you can have two transformers running in parallel. But keep in mind, so basically what the TT system is, you need to have only one point of source earthing. But why I'm highlighting this is, when you go for the other type of installation, that restriction is not there. You can have multiple earthing in the source side. This is only for the source side because the source is isolated from the installation. Okay, so that then you have a separate earth in the installation side, separate earth electrode, so that they are electrically separated. So you don't have any connection in between. So that here you can see your transformer or your generator, whatever device, even if you have nowadays people are using solar PV. So even off-grid systems, so that you have the inverter. So that is the source. So that you need to have a neutral point earthing at the source side. So it's a single point earthing, one point earthing, and that is totally separate to the installation or building earth. So you are not connecting building earth to your source. So as a classic example is, if you look at even an off-grid inverter is a source. So that your off-grid inverter earth and the building earth or the house earth, you cannot connect them together. That should be totally separated. Even if you have a generator, if you are wiring as a TT system, then they need to have a separate earth electrode. So it's separated from the building earth. Even a transformer, generally most of the location transformers are provided by the utility. They maintain their own earth separator, and your building earth is separate, so that they are electrically separated. So that is what we call as a TT system. The transformer, generator, or even off-grid inverter, they have their own earth, but the installation side, building side, I have separated. But especially if you are having a grid tie inverter, you cannot have a neutral point earthing at the grid tie, because the transformer is providing your neutral point earthing. Likewise, there are certain requirements which you have to follow. So the strict rules are there, so that you have to understand that strict rule and implement it very carefully rather than mixing up those requirements. That is the first type of earthing arrangement. Second type we call as a TN. So that here, now instead of maintaining your own earth, you connect your exposed conductive paths to the neutral point. So that neutral point of the source. So that's why we call them as a N. So here you have a C. C means the neutral and earth, what we call as technically we call as a protective earth. The neutral and protective earth are combined together. You don't have two wires. The both neutral wire and the earth wire are combined together. So that is the simple explanation, where you have the source earth. Now in the installation side, you don't have the separator. You are connecting all exposed conductive paths to the neutral at the load point. So that here you can see, as I said, as per the definition, you can have multiple earthing. So that now you don't want to maintain single earthing here. So that even if you want, you can have additional earth here, like that, or any other earth here. So that because you are neutral, work as your earth, the conductor, so that you can connect multiple earths there, so that creating a okay, good thing. And because you are connecting them together, you need to have, you can maintain, okay, have different earth electrode and different thing, but they are connected together, not separated earth. So they are connected together. That we call as a TNC. So then similarly, so the one of the problem with the TNC is, you can see here, if there is a earth fault, so the detection is very difficult, and because the currents are flowing through the neutral, so that you don't have a residual current in the TNC system. So that because of that, earth fault detection is very difficult in the TNC system, and some of the countries are banned because of this the problem. And when you go to Singapore, you will see that they are also following the BS 7671, but they specifically says in their standard, so they are not allowing for the TNC systems for a high rises, those type of location. So that type of requirements are there. That is what we call as a TNC system. Even in Sri Lanka, very rarely we are getting this type of TNC systems. Then we have the TNS. The main problem with the TNC is you don't have a separate conductor, or there is no residual current. Now you are creating a residual current. If there is a fault occurs, so now the current is flowing through the separate path. So that is through your earth conductor. So that now we are maintaining separate the earth rather than connecting it with the neutral. But you can see at the source point, your neutral and earth are combined together. And even here, when you maintain a TNS system, you can see it also says one or more earth. Okay, you can use multiple earth. Even if you want to have a separate earth here, you can have a separate earth, because that is also connected to the same PE conductor. Even if you want to have a additional earth here, you can connect them because they are combined together, so that you can have a multiple earth points, but they are connected, electrically connected together, so that even within the installation you can have a earth. And even if you have a cable or any other connecting point, you can have multiple earth. Compared to the TT system, now that is the main difference between the TT and the TN. So that this is what we call as a TNS. But when you look at this system where the cost is high, because you have to maintain a separate wire throughout the installation. Then the third one is we can have the combination of TNC and TNS. Part of the installation is TNC and the part of the installation is TNS. That we call as a TNCS. So you can see in here, you don't have a separate earth cable and the neutral cable. Earth and the neutral are combined together. But within the installation, you have a separate earth cable and a separate neutral cable. So that system we call as a TNCS system. So that that is the fourth category of distribution system we can use in our electrical installation. So that here, this is our source earth, so that because the exposed conductive parts are also connected to the source earth neutral point. Then the last one, what we call as a IT system. So that in the IT system, basically the source is unearthed. Source neutral point is unearthed. And the installation side, you are maintaining a earth electrode. All the exposed conductive parts are connected to a earth electrode. But you can see now your transformer, your generator, those type of things are unearthed. So that a neutral point is unearthed. And because of that, you can see even if there is a fault occurs, so that there will not be any circulating current, because you don't have the neutral earthing. So that because of that, you will get only very negligible current, even a very small capacitance. Other than that, no any current. So that even if you not get electric shock, because it's another point. But these are not allowed in the relation. We can use this one for we are not okay, not of the circuit even condition, because there are very where even you don't want to disturb your supply. So for example, like an operation theater, when the doctor is doing the operation, so if something goes wrong, you cannot disconnect the operation theater, or you cannot disconnect the supply to the operation theater. So that in that case, you can run that operation theater as a IT system. Even for example, data center, so that if the leakage happen in your the servers or the computers, you cannot just cut off your supply. So because if you cut off the supply, that can disturb entire the actions happening in the servers. So even the transaction, whatever things can disturb, and because of that, you can run that type of system as a IT system, like where even if there is a fault first fault occurs, nothing will happen. Okay, you can have certain type of monitoring devices to detect that fault, but you don't want to disconnect the circuit. So those are for the special installation, but this is not allowed to use in a public places. So now, when you look at all these different type of the systems, you can see we have the TT, TNC, TNS, TNCS, as well as the IT. So that simply now, as per the standard, all are allowed. All are allowed. But keep in mind, when you look at our distribution system, so low voltage supply, so the utilities are not maintaining a separate the PE conductor separator. You can see most of these overhead lines are coming with 4 wire, that is 3 live and the neutral. No, the earth wire is continuing from this transformer, and because of that, when you look at our the earthing system, especially for the low voltage customers, that is if you are taking a 230 supply or 400 volts 3-phase supply from the distribution the line, so those are what we call as a low voltage customers. So they have to be designed as a TT system, because obviously your transformer is maintained by the utility. They have their own earth electrode, and you have to maintain your own earth electrode. They are electrically separated, so that all the installation, if you are planning to take a low voltage connection, then that need to be designed as a TT system. But there are installation that is the low voltage customers are categorized as if they have a demand less than 42 kVA. But if your demand is more than 42 kVA, the CB and LECO will not allow to get the distribution connection. They will insist you to install the dedicated transformer. That we call as a bulk consumers. We have 2 type of bulk consumers, LV bulk and the HT bulk. So that okay, now you have your own transformer. It's not a public transformer. It is dedicated for your installation. So that if you have a dedicated transformer, then it's up to you to decide whether to go with the TT or TL. So whatever, as I said, we cannot use the IT for those type of public installation, but you can design it as a TT or TA. But as I said, IT you can use as a part of the installation. So the certain part, now if you are designing a hospital, so the general areas of the hospital you can design as a TT or TN. It's up to you. But operation theater, you can design, if it is a critical operation theater, you can design it as an IT system. Similarly, for example, if you have a building, so that the normal building, public building, you can design as a TT or TN if it is a bulk supply. But within the building, if you have the data center, a part of the location is allocated as a data center, and a critical the requirement. In that case, that data center you can supply, you can take the TT or TN supply and put a separate transformer and then run it as a IT system. Likewise, for a dedicated or special installations, we can use the IT, but not for the public installations. So now, so that is the main thing you have to keep in mind. In Sri Lanka, as per our country's law, so that that is the regulation, so that you can use whatever, like as I said, so that if it is the LV distribution, you have to design it as a TT. It is a bulk consumer, you can design as a TT or TN, whatever, up to you. And then, so if it is a special installation, which where the supply is critical, then you can use only that part as a IT system. And then the other most important thing is whatever the LV distribution you use, you need to have a very good protection scheme. So that the protection, basically we the subdivide into two parts. One is, as I said, we have to provide the human protection. That is the number one priority. When you look at the human protection, human can get electric shock due to the whatever the abnormality. So that you have to protect humans against getting direct electric shock. That is, they can the touch live part directly and get an electric shock, or else they can they get indirect the electric shock as well, because there can be a certain fault, and for example, like exposed conductive parts can get a certain type of the leakage. During the leakage, if you the touch those exposed conductive part or your outer body of the appliance, you can get electric shock, because normally you can touch the outer body, but in this case, due to a fault, you will get an electric shock. So that direct contacts, we call them as a basic protection, so that you have to avoid all the possibilities of people getting direct contacts. And the second one we call as a fall protection. That is, person get electric shock due to the leakage. Leakage is a fault. So that is the second one. And also the people can the burnout, and there can be arcing and burning due to thermal effect. So that again, the people can damage or get injured due to a thermal effect. So that you have to give certain protection against the thermal effect as well. That is the human protection. Then we have the equipment protection. Equipment protection, there can be short circuit, that can be live to live, live to neutral, or whatever fault can occur. So that, and also there can be overloading and short circuiting, whatever things can happen. So that we have to, if that happen, then you need to have a certain scheme that will take care of those type of things. So that also can create certain thermal effect. So that, you can see, in order to protect the human, you need to have a protection, thermal effect, the protection against thermal effect. And also you have to protect the equipment, so that there is a protection against thermal effect as well. Then you have the equipment protection. The equipment can damage, that is your cables, your other appliances can damage. One thing is due to a short circuit situations. And the next one is due to a overloading situation. So that both of them, short circuit and overloading, we categorize as a overcurrent condition. So that you need to have a overcurrent protection. So then when you look at the even indirect contacts, that is the fault happening and the short circuits, both of them are fault, because even in the indirect, person get electric shock due to a fault, and other damages can happen also due to a fault. So that the indirect contacts and the short circuits, we put it to a same basket, and we say that as a fault protection. So that all of them, you can see, it's basically due to a current leakage or whatever things. Even people can get damaged or equipment can get damaged. And other than that, the next one is what we call as a voltage disturbances. Not only the current, but also voltages can create certain disturbances. Even surges, lightning surges can create disturbances. and damage equipment, and due to that one, fire can occur. Likewise, many things can happen, and that we call as a protection against voltage disturbances. Okay, so that when you look at the LV distribution system, no matter whether it is TT, TN, or IT, you need to provide all these protection requirements. So that's okay. If you neglect one of them, that means you are violating the regulation. So that if something goes wrong, even if you have not provided the protection, you can get to you can put it to a court as well. So that is the requirement. Keep in mind, these are the schemes, protection schemes you have to apply for a low voltage installation. So now, as I said, we give the first priority for the human being, so that the human can get the electric shock due to direct contacts or indirect contacts. And in order to provide protection against electric shock, so you have to provide the basic protection and the fault protection. I'm not going to go in detail, but keep in mind the regulation gives us very clear guideline how to provide the basic protection. These numbers are the regulation numbers, so that you have to provide the basic protection and the fault protection. So now, when you look at if we want to protect people against electric shock, so it can be either TT system, TN system, or IT system, whatever. What the standard says is you have to provide the certain protective device to protect protect against electric shock. So that you need to provide what we call as a automatic disconnecting devices. So that can be overcurrent protective device or residual current protective device, but specially so that whatever TT, TN, or IT, you can provide the protection by these devices. When you go to IT system, in the IT system, so because you have a isolated neutral point, the fault detection is very difficult, and because of that, there are special equipments. Those are what we call as monitoring devices. So generally we call as insulation monitoring devices, or the certain insulation fault locating devices. Whatever name can be there, but you need to have a monitoring device in an IT system, because none of the other devices will work in the IT system. You need to have a special device in the IT system. Now, again, when you look at the standard very clearly says what type of devices you can use in these different type of the distribution arrangement. TT, you can see now, even though the standards that says so that you can use either residual current or the insulation monitoring or overcurrent devices, but the standard also says that generally we are not recommended to go for the overcurrent devices, because you need to have a residual current device to detect the fault situation. But for the other fault, like short circuit fault, you can use the overcurrent devices, but for the earth fault protection, you need to have the residual current device. T and C, you can see residual current devices are not allowed. So you can use only the overcurrent devices, because in the T and C system, you don't have a residual current. T and S system, you can see either residual current device or overcurrent device, or both together we can use as the protective device. T and CS are also the same. And when you go to IT system, now you can see the TT system, the recommended thing is the residual current device. But in the IT system, residual current devices are not recommended. But you have to go with the insulation monitoring device for the single fault protection. And if you have double fault protection, then you have to go with the overcurrent protective devices. So that these are as per the standard, these are the requirement, and also the breaking condition, how to select their sensitivity values are also mentioned in the standard. So that these are some of the things you should very carefully set when you install any type of protective devices for any of these type of the distribution systems. And also not only the protected device, but if you put a protected device, one is we have to set the correct setting. So the correct setting you have to calculate and put it in by using these equations. And then you have to set the maximum delay time as well. So that you can see for the TT and TN, if you are using normal 230 supply, so that either DC or AC, so that there is a maximum delay time you can allow for your protective device. You cannot have a delay more than this value. If it is a TT system, the low voltage, if your circuit is less than 32 ampere, your time delay should be less than 200 millisecond. And TN system, you can go up to 400 millisecond. That is up to the 32 ampere circuit. All our end level distribution boards, you need to have this type of requirement, so that normally we are using the instantaneous tripping, but maximum allowed the delay time is this one for the if the circuit is less than 32 ampere. But if the circuit is more than 32 ampere, if it is TT, you can go up to 1 second. And if it is a TN, you can go up to 5 seconds. So that is a requirement. So if the circuit is more than 32 ampere, that is the requirement for current setting and the time setting. So then,
Dr. Asankar.
Yeah.
Sorry to disturb, and I would rather happy if you can take 2 minutes time to summarize in single as well, somewhere in benchmark areas which
okay.
as we discussed, please.
Yeah. Okay. Right. Mama the method karapu part එකේ දැන් මම explain කරපු විදිහටම ලංකාවේ තියෙන විදිහට ලංකාවේ අපි follow කරන්නේ BS 7671 ඒක legal requirement එක. ඒක නිකන් just a practice එකක් නෙමෙයි, it's a legal requirement එකක්. ඒක අනුව අපිට පාවිච්චි කරන්න පුළුවන් තියෙනවා earthing arrangements පහක් identify කරලා. TT system තියෙනවා, TN system තියෙනවා, IT තියෙනවා. TN ඒවා අපි subdivide කරනවා තුනකට, TNC, TNS and TNCS. ඔක්කොම අපි decide කරන්නේ the source එකේ neutral point එක earth කරලා තියෙන විදිහටයි. ඊළඟට අපේ installation එකේ අපේ තියෙන exposed conductive part, ඒ කියන්නේ outer body ටිකේ earth ටික කොහොමද අපි earth කරලා තියෙන්නේ කියන එකයි. එතකොට මේ දෙක separate අපි building එකේ වෙනම earth එකයි the transformer හරි generator වෙනම earth එක විදියට තියෙනවා නම් තියෙන්නේ අපේ TT system එක. ඊට පස්සේ මේව අපිට connect කරලා නම් transformer earth එකයි building earth එකයි මේ ඔක්කොම එකට connect කරලා තියෙනවා නම් යන්නේ TN system විදියට. ඊට පස්සේ IT එකේ main එක තමයි IT normally public installations වලට allow කරන්නේ නැහැ. ඒක allow කරන්නේ special installation වලට. එතෙන්දී අපේ transformer එකේ neutral point එක secondary side neutral point එක isolated. ඒක නිසා even IT system එකේදී කවුරු හරි ගිහිල්ලා live wire එකක් ඇල්ලුවත් ඒගොල්ලන්ට harm එකක් නැහැ. මොකද circulating current එකක් generate වෙන්නේ නැති නිසා. even fault එකක් වුණත් පළවෙනි fault එකට කිසි ප්‍රශ්නයක් නැහැ. මොකද neutral point එක isolated නිසා අපිට even අර insulation failure එකත් එක්කම run කරන්න පුළුවන්. ඒක නිසා තමයි IT systems allow කරලා තියෙන්නේ only for අර කියපු special installation වලට. අනිත් ඒවා ටික අපි ඕන තැනකට පාවිච්චි කරගන්න පුළුවන්. එතකොට මේ විදිහට installation තියෙනකොට අපි basically අපි දෙන්න ඕනේ protection the installation එකේ. ඒක අපි TT දෙයන්නේ TN දෙයන්නේ IT දෙයන්නේ කියන එක matter එකක් නෑ. ඕනම low voltage installation එකේ මෙන්න මේ කියන the basic protection ටික provide කරන්න ඕනේ. ඒ කියන්නේ basic protection එක, fall protection එක, ඊළඟට the short circuit protection එක, thermal effect වලට protection එක, overloading protection එක සහ voltage disturbances කියන protection ටික තියෙන්න ඕනේ ඕනම installation එක ඒකේ අඩු වැඩි තියෙනවා කොහොමද setting කරන්නේ මම මුලින්ම පටන් ගත්තේ the electric shock වලින් කොහොමද people protect කරගන්නේ කියන එකට ඒකට අපි protective device එකක් දාන්න ඕනේ automatic device එකක් එක්ක basic protection ටික දෙන්න ඕනේ එතකොට automatic device එක මොකද්ද select කරන්න කියන එකත් standard එකේ කියලා තියෙනවා එතකොට අපි standard එකේ අනුව එක්ක අපට overcurrent devices RCD කියන්නේ residual current devices so සාමාන්‍යයෙන් අපි කියන trip switch විදියට trip switch කියන්නේ හරි terminology එක නෙමෙයි ඒක හරි terminology එක තමයි residual current device එක කියන එක එහෙම නැත්නම් අපිට පුළුවන් IT system වලදී insulation monitoring devices යන්න even insulation monitoring device එකක් ඕනම තැනකට දාගන්න පුළුවන් නමුත් IT වලදී ඒක compulsory කරලා තියෙනවා මොකද අනිත් device වලින් අපිට earth fault එකක් detect කරන්න බැරි නිසා ඒකට ඒ වගේ අපි current setting එකයි time setting එකයි set කරන්න ඕනේ ඒවටත් standard එකේ very clearly කියලා තියෙනවා කොහොමද අපි select කරන්නේ මේ වගේ current setting එක කොහොමද අපි මේ වගේ select කරන්නේ time setting එක කියන එක. එතකොට මේ protective device වල අපි set කරන්න ඕනේ අපි මොන හරි ගන්න device එකේ කීයද maximum the current setting එක කීයද ඒකේ තියෙන maximum time setting එක කියන එක අපි බලන්න ඕනේ. එතකොට මේ ටික තමයි basically මේ ටික මම cover කරේ. So then when you look at this RCD selection, that is the residual current devices. Residual current devices can be either, so there are various different type of residual current devices. One commonly used one is the residual current circuit breaker, RCCB. අපි normally කියන්නේ trip switch කියලා. So trip switch is not the correct terminology, but that is the correct terminology is RCCB. Or even we can use RCBO, residual current over current protection, that we call as a RCBO. Or there are EFR, ELR, whatever the earth fall relay, earth leakage relay, whatever can be used. But you can see when you look at the TNC systems, residual current devices are not allowed. Keep in mind, it is not allowed. So, but all the others, you can use the residual current devices. In the IT system, again, residual current devices are not recommended because you cannot detect the earth fault by using residual current device. When you look at the TT system, now the residual current device setting, you have to set based on your earth electrode resistance value. So that you can see, so depending on you can consider even vice versa. So when you are, if you have a 30 milliampere the trip switch or the residual current device, you can go up to 1667 ohm earth electrode resistance value. But even that, what the standard says is, if you go with these type of things, you are not allowed to go your earth electrode resistance more than 200 ohms. So that any electrical installation, so if your earth electrode, that is your separate earth electrode resistance goes more than 200 ohms, so that is not applicable. So that means if you are using 100 milliampere or 30 milliampere RCCB, so you can go up to 200 ohm earth electrode resistance. But if you are using any of more than that value, so then your earth electrode resistance should be reduced based on that value. So that is the requirement mentioned in the standard. There are calculations where you can do, but I am not going to cover those type of things detail. But keep in mind, standard very clearly says that, okay, how to select this residual current device. So it's not just picking whatever available in the market and put into your installation, but you have to select them correctly, your time setting as well as the current setting, and also you have to decide your earth electrode resistance value depending on your residual current device setting. So that you have to keep in mind. So all are interrelated, so that they are not, okay, one value for the earth electrode and you can without looking at the earth electrode resistance, you cannot pick your residual current device in the TT system. And the other misconception in the industry is people think that if you put a residual current device or trip switch, you can prevent all the people against the electric shock. Keep in mind that is very wrong idea, because even the trip switch or your RCCB can trip off if a person get a direct stroke or direct electric shock. But during that time, what is happening is there is a current flow to the body, so that the person will get electric shock, and only after that your trip switch will trip off. So that because of that, keep in mind, so the trip switch or your residual current device is not a device to prevent. Okay, so that will reduce the injury, but it's not preventing electric shock. So that normally when you look at the people's behavior, so the people's behavior is so that they follow this type of a curve, where normally if there is a body current less than 500 microampere, you don't feel anything. So that is the reason, so that even there can be a current flowing through my body throughout my lifetime, I can bear that current without any problem, so that even I don't feel it. That is, if the current is less than 500 microampere. So, but if the current increases, you can see up to about 10 milliampere. You don't, you feel something, but no harm. But the problem arises when the body current goes beyond 10 milliampere. So when it goes beyond 10 milliampere, you can see your exposure time reduces. Because now, for example, when you look at the 30 milliampere current, we can withstand something like a 500 millisecond. So in an average person can withstand 500 millisecond, not more than that. So if we expose to more than 500 millisecond, then the person get electric shock. So, and even he can he can die due to this electric shock situation. That is the situation. Now, as I said, so this is where you are getting the irreversible effect, so that even though your heart muscles can stuck, and then that will stop the blood circulation through the body and creating even a sudden death if the current goes beyond that limit. So that likewise, you can see when you go to something like a 1 ampere, 1 ampere instantaneously, you will get electric shock. So that it's not, you cannot bear it for even the microsecond period, you will very quickly get an electric shock. So that now keep in mind, when you look at the 30 milliampere, you can withstand something like a 500 millisecond time period. Now, let's say if somebody touch a live part, like something like a 230 volts, what will happen? So generally, human body resistance is something like on average 1.5 kilo ohms. So if you look at that one, so you will see that if I touch 230 supply, so then there will be a current flow through my body, something like 153 milliampere. So now close to 150 ampere. So that you can see if I have 150 ampere, so now I can withstand only 90 millisecond. 90 millisecond. So if this current flow to the body more than 90 millisecond, then that is my end. So what the residual current device does is, now you can see if I use a 30 milliampere residual current device, that will trip off within 40 milliseconds. So obviously less than 90 milliseconds. So that I will not go to the death situation or irreversible the situation, but I'll get an electric shock. But after getting electric shock, the supply will disconnect, so that I am anyway safe. That's why we are using 30 milliampere or lesser residual current devices to prevent or to avoid the injuries due to electric shock. This is just reducing the injury. මතක තියාගන්න the trip switch එකක් දාපු පළියට අපි electric shock වලින් මිනිසුන්ව ආරක්ෂා වෙන්නේ නැහැ. The trip switch එකෙන් කරන්නේ එයා අර තියෙන time එක අඩු කරනවා. exposure time එක අඩු කරන එක විතරයි කරන්නේ. නමුත් current එක ඔයාගේ ඇඟෙන් ගිහිල්ලා තමයි trip switch එක trip වෙන්නේ. ඒතර ඒක නිසා මතක තියාගන්න RCD කියන එක අර human the protection device එකක් නෙමෙයි, it's an additional protection. It's keep in mind you can use RCD as an additional protection, but you have to provide the basic protection separately so that by providing whatever milliampere range, RCD will not prevent you against electric shock. You will get an electric shock, but you will not get the certain serious injuries. That is the idea. So because of these reasons, and because the people are interpreting these things in a different way, so that in this 18th edition, this requirement was revised. So that now, so this the additional protection by the RCD not exceeding 30 milliampere is now imposed to all the socket outlet. So if you have a socket outlet, so where the current is less than 32 ampere, definitely that need to be protected with the 30 milliampere. So it's a mandatory requirement because it's enhanced the requirement. And also if you have any mobile equipment where people can use handheld equipment or any other type of device, then definitely whatever device you use, so if the current of that device is less than 32 ampere, that circuit should be provided with the RCD with less than 30 milliampere the sensitivity. So these are new addition to the standard. So and also keep in mind this is not valid for the ELV systems. ELV systems like FELV systems, you will learn about those things in detail in the coming lectures, so that this RCD requirement is not there. So if you have ELV systems or FELV systems. And also especially this requirement is mandatory for the dwelling, that is housing, apartment, those type of things people are living. So those type of location, RCD is mandatory so that you cannot deviate from that. But there are some other locations where you can do the risk assessment, and if you have a documented risk assessment, other location, if you want to omit the RCD, so then you have to do the risk assessment, and then you can do you can avoid. If there is minimum risk, then you can avoid the RCD. Otherwise, RCD is mandatory as per this new the amendment. So just putting RCD is not enough. Other thing is you need to have a very good earthing arrangement, so that when you look at the installation, you need to have what we call nowadays is the equipotential bonding. All your exposed conductive part, all your other metal parts, so you have to connect them together, and you have to take it to a main earth terminal, and then you have to properly earth them. Depending on whether it is a TT or TN, you have to earth them properly. So when you look at these things, you can see in our system, so just providing the RCD is not enough. You have to have the equipotential bonding as well. Then only, otherwise your current will flow through your body, creating an electric shock, and then only RCD will operate. So that to prevent that one, what we have to have is you have to have a permanent earthing connections of within the installation, so that all the exposed conductive parts you have to connect to a common point, and then that should be connected as a separate earth electrode to a separate earth electrode, or it should be connected to the source neutral point, whatever way you have to do. Now in here you can see there are different type of cables. One we call as a protective conductors. that is which are coming from electrical equipments. And also non-electrical equipment, we have the bonding. Those are what we call as the protective bonding. Then from the main earth terminal to the earth electrode or the transformer neutral point, we have the earth conductor. So those need to be sized precisely and use it, then only you are providing a safer installation. So that and also there can be supplementary earthing as well. So that the other than the, now here you can see that you have the main earth conductor, and other than that, all the other here also this metal part, you have the main equipotential bonding, but you can maintain a supplementary in between these two. They are additional, they are not mandatory, but if you want, you can connect them together and creating everywhere in the same potential. That is the idea. So now, so there is a strict requirement to select the protective conductor. Standard gives us how to select the protective conductor. Either we can use the adiabatic equation or we can use a simplified method. So that you can see when you look at the requirement, the first option they are giving is the calculation. You have to calculate your fault current, and then you have to decide your earth conductor requirement. Or else, if you are not doing the calculation, you can go for the selection. So as per the regulation, so then depending on your the phase conductor size, you can select the earth conductor. So that is very clearly given in the standard. And also when you look at these protective conductors, not only the cable, you can use the single core cable, you can use a conductor of the multi-core cable, or you can use any other like the conductor, insulated or bare conductor. So there are many options are there. Not only, it does not say that you have to use only a cable or separate cable, but there are many other requirements. Even you can use any other the conductor, if it is copper not less than 10 millimeter, so you can use as your protective conductor. So that any material, even if you have an armor, so the armor of the cable you can use as a protective conductor. Whatever metal part with the sufficient cross section, you can use as your protective conductor. That is the number one. Then you can see in that previous diagram I had bonding. One is a protective conductor, other one is protective bonding. Protective bonding, you are deciding based on your neutral conductor size. So that if you are you have to look at your installation, what is the neutral conductor, main supply neutral conductor, and all the other non-electrical equipment. So there can be even metal, the aluminium, the door, windows, those type of things are the non-electrical equipments. There are many non-electrical equipment within the building. So what the standard says is all of them need to be connected to our equipotential bonding. So that need to be done using the protective bonding. Their conductor sizes are also given based on your supply neutral conductor size. So that if it is a less than 35 millimeter, the neutral conductor, so then you can use 10 millimeter squared cable for this protective bonding. So if it is 35 to 50, so then 16 millimeter. Likewise, you can see there is a strict requirement for the protective bonding conductor. Then again, you have the supplementary bonding. These are, you can see sometimes people use everywhere, okay, this is my earth conductor. But you can see each and every part, they have specific name and specific way of selecting the sizes. So that likewise, okay, even for the supplementary bonding, so that is additional bonding, there is a minimum requirement. So that if you are using the copper conductors, or if it is the mechanically the protected conductors, you can use 2.5 minimum requirement. And if it is without mechanical protection, so at least you need to have a 4 millimeter square. Those are the supplementary bonding. So like that. So there are strict requirements so that now you can see, you cannot name them as all as my earth cable. So people use like that. But you can see now there are circuit protective conductors, protective bonding conductors, and the supplementary bonding conductors as well. Those three should be sized separately and correctly, and you have to run with the installation, and you need to have the protective devices, correctly selected protective devices, then only you are providing this protection requirements. And then you have from your main earth terminal to your earth electrode, you need to have the earth conductor. Earth conductor selection is also very clearly given in the standard, so that depending on the fault current, these are the minimum requirement. You cannot reduce the conductor size less than this value, but depending on your fault current, you have to calculate the fault current, and then you have to size your earth conductor depending on the fault current passing through the earth conductor. Likewise, you have to do very the detailed calculation, and due to a time limit, I am not going to go in detail, but just keep in mind, because just putting whatever the available conductor is not enough. You have to have a correctly sized earthing conductors in this installation. And also keep in mind, when you look at this earthing, so sometimes people are maintaining different earths. Like sometimes people call them as a panel earth, my clean earth, instrumentation earth, like that. Okay, if you define like that, you can define so many different type of earth. So the dirty earth, the computer earth, the instrumentation earth, structural earth, like that. But keep in mind, so there is nothing like that. So that we have only one earth. So whatever we connect to the earth, so that we call as a earthing. So that there is no concept called dirty earth, clean earth, computer earth, the telecom earth, lightning arrestor earth. Those type of terminologies are not used by the standard. So what the standard says is, so the whatever things you are connecting to the earth, mass earth, that is called as a earth. So that you are not defining lightning arrestor earth, the dirty earth, clean earth, like that. So that now, as per the IEC also, what it says is, you have to have a equipotential bonding, so that don't maintain separate earth within the installation. So that within the installation, now, as I said, if you have a TT system, you need to have a source earth separately, installation earth separately. Other than that, so within the installation, if you are maintaining lightning arrestor earth, telecom earth, sometimes the telecom supplier will come and put a separate earth, and a solar panel supplier will come and put their own earth, and your panel, you have your own separate earth. That is not allowed. Keep in mind, that is not allowed. So that within the building, you have to maintain equipotential bonding, so that you can have multiple earth electrode, but everything should be connected together and creating a equipotential bonding. So that is the requirement. But if you are maintaining TT system, then your transformer or the generator, whatever supply, even if you are maintaining the off-grid PV system, that neutral point earth should be separated from the installation. Other than that, so all the other earth should be connected together. Okay, connected together, so that you can create a three-dimensional earthing, so that whatever within the building, everything should be connected together, and then create a equipotential bonding and do this type of a earthing arrangement. So this is very easy if you do the design initial stage, so that nowadays the best practice is you can use a structural earthing. So that, because when you look at the structure, you have massive amount of rebar, and even in the foundation, you are having massive amount of rebar. So especially like a high-rise building and many buildings, you are even creating the foundation of footing, so that that footing we can use as a earth electrode or earthing system, because concrete under the moisture condition is a very good conductive material. So that if you bury a concrete in a soil, so that absorb the moisture, because the concrete is a porous. So it has small holes. They absorb the moisture and retain the moisture. So under the moisture condition, concrete is very good conductive material, and the foundation already contains massive amount of rebar, so that you can use the rebar as your foundation thing, but you have to design it from the beginning. So if you do like that, so that you can maintain the equipotential bonding within the installation without any problem. So, okay, other than that, so now you can see we need to have the RCD, we need to have the basic protection, and also we need to maintain the equipotential bonding within the installation. But when you look at the new regulation, 18th edition, and its amendment, that also talks about this thermal effect and putting a high attention on the thermal effect, because you can remember that there was a certain fire incidents happen in the UK, and entire even the apartment complex was damaged, not only one few, the damage due to this fire. So that the root cause of that fire was found as that is due to electric the leakage or the electric fault. So that because of that, a new standard also highlight that this arc fault detection is also a mandatory requirement. So that arc fault means, normally if you look at if you have a live to neutral or live to earth fault, so that if you have a live to neutral or live to live fault, that we can detect by the overcurrent protective device, MCB or fuse, whatever, that will detect that fault. But if you look at the live to earth fault, if you want to detect the live to earth fault, you need to have a residual current device, so that that residual current device can detect live to earth fault. But let's say if you have a certain type of the loose connection, so that those are what we call as that can create hotspot. So that if you have that type of things, neither MCB or RCD will trip off or will detect that one. So that the standard identified that issue, because they found that mostly these fires are occurring due to hotspots and the loose connection or damaging of disconnecting the live wires like that. And because of that, you need to have a certain protective device. So that protective device, what we call as a arc fault detection device. So AFDD. So that is a new requirement. So they have imposed new requirements, especially because you can see mostly now, even in Sri Lanka, we are getting a lot of high rises and a lot of buildings which are public locations, which can easily initiate the fire. If the fire occurs, that can spread throughout the building. And because of that, this arc fault detection is recommended for especially like a sleeping accommodation. So if it is the house or apartment building or even a hospital where the patients are sleeping, so that if it is that type of location, now the arc fault, the detection is mandatory or is recommended. Or if there is a fire risk, there are certain storage material which can easily spread the fire, and also there can be certain combustible material, so that if so, then this arc fault detection is compulsory. So that that will be the new addition, so that you can see these thermal effects are mandatory nowadays. And other things are okay, like overcurrent protection and the short circuit protection. Those are also needed, so that you have to do the calculation and check whether what is your the fault current and the loading requirement, all of them, and then decide your protective device correctly. Now you can see, so that when you look at this system, basically your basic protection, fault protection, thermal effects, all are covered very clearly, but you have to do a correct calculation and then decide what is the required protective devices. That is very clearly given in the standard. So that other than that, I will quickly give the last part. Last part, you can remember that the last protective scheme is the voltage disturbances. So that the voltage disturbances are also added in the edition, so that when you look at the previous edition, like a 17th edition, you can see this 534 is empty. But when you look at the new 18th edition, now 534, there is a very descriptive guideline to how to select this voltage disturbances or how to protect the installation against the voltage disturbances. So that keep in mind, because of that, this is also now become mandatory requirement. That is, the surge and the lightning protection has become a mandatory requirement. It gives a very clear guideline how to select SPDs, how to size the SPD. Due to a time limitation, I will not go in detail, but keep in mind, so there are ways and means of selecting devices. There are different type of surge protective devices which are recommended for some installation and which are not recommended for some other installation. Likewise, now, for example, if you look at the certain installations are not recommended for the TT system, and certain are not recommended. Now, for example, when you look at the SPD connection, we have two type of SPD connections. One we call as a 3+1, other one we call as a 4+0. So the 3+1 is, here you can see I have 3 SPDs for 3 live wires and one from the neutral to earth. And the 4+0 means, you can see, so I have 4 SPD, that is for the 3 lives and the neutral. So then from there, you have the earth connection. Now, when you look at the TT system, you are not allowed to use 4+0 unless you have the residual current device in front. If you do not have a RCD in front of the SPD, you are not allowed to use this type of 4+0 in a TT system. But if you use a RCD in front of the SPD, main problem is RCD can trip off, because every time when the SPD discharge a current, that will be detected as the faulty situation or the earth fault situation. So that the RCD will trip off if you put it like that, so that there should be a certain the nuisance trippings if you go like that. That's why in the TT system, this 3+1 is the recommended one, where you can use your RCD after the SPD. Likewise, there are certain requirements which you have to comply. So these are new additions. These are new additions which you have to very carefully look at your installation and do it. So that with that, okay, I will stop my the lecture, because we want to have certain discussion. Probably I know that you have a lot of questions, but as I said, within this 1 hour, 1.5 hour time period, I cannot cover everything, but I tried my best to cover whatever the most important part which are needed, where you have to put high attention, because now your requirements are different. Now you have very sensitive the electronic devices within your LV supply, so that most of your equipments are now very sensitive, and they are with power electronic devices. You cannot run it in a normal way, where you need to have a very sensitive or very the comprehensive and very active protective devices. Otherwise, you cannot run the system correctly. So that's why. So the standard very clearly says us what type of requirements are there, how to put protective devices, how to maintain earthing system, so that if you select the protective devices correctly, and if you maintain your earthing system correctly, you can run the system without any the problem. So the most of the times you are getting the problems. One thing is most of the cases you don't have a correct protective devices, correctly sized protective devices, as well as you don't have a correct the earthing system. So if you are having incorrect earthing system and incorrect protective devices, that will create a lot of problems. So that's what I want to highlight, so that if you are working in the industry, now keep in mind, so we have the country's law, so that the following the BS 7671 is a mandatory requirement. ඒක නිසා මතක තියාගන්න, දැන් මේ BS7671 එක follow කරන්න ඕන කියන එක is a law. The very clearly gazetted the law, so that ඒක නිසා මේ හැමතිස්සම අපි මේක follow කරනවා නම් මේකත් එක්ක update කරන්න ඕනේ. මම අර ඉස්සලා කිව්වා වගේ දැන් තියෙන අලුත්ම standard එක තමයි the 18th edition with the amendment number 2. Keep in mind ඒක publish කරේ ජනවාරි වල මේ අවුරුදු ජනවාරි වල හැමතිස්සම publish කරන අලුත්ම regulation එක හොයාගෙන ඒක follow කරන්න සහ ඒක very clearly the study කරන්න එහෙම කළා අපේ electrical installation එක maintain කරොත් එහෙම ඔය එන ඔයගොල්ලෝ practically මුහුණ දෙන ගොඩාක් problems අඩු කරගන්න පුළුවන්. Thank you very much. මම හිතන්නේ අපි මොන හරි ඔයගලන්ට ප්‍රශ්න තියෙනවා නම් ඒ ටික අපි තියෙන ඒවා ටික time එක අනුව discuss කරමු. Thank you.
Thank you very much. As you well explained that this is not the suitable or enough time to explain everything, but I think you have covered a lot of areas, and especially with the latest updates and important areas. So thank you very much, sir. And for all the participants, now we have put our attendance sheet at the Google as a Google form in Zoom chat as well as in the YouTube live streaming. So we will keep it for next 15 minutes, this attendance sheet. So therefore, please mark your attendance, which is essential to obtain the certificates particularly. So then සියලු දෙනාටම බලන්න පුළුවන් attendance sheet එක දාලා තියෙනවා Google form එකේ සහ YouTube live streaming එකේ. ඒක අනිවාර්යෙන් mark කරන්න. ඒක mark කරපුවම ඒක automatically Google form එකක් තියෙන්නේ. ඒක automatically අපි ගාව record වෙනවා. ඒ recordings තමයි අපි ඉස්සරහට බලාපොරොත්තු වෙන්නේ පාවිච්චි කරන්න. certificate එක දෙන්නේ attendance හැටියට. ඊට අමතරව මොනවා හරි power failure එකක්, signal drop එකක් හරි මොනවා හරි දෙයක් වුණොත් එහෙම ඔයාලා තින් අපි recommend කරන්නේ screenshots දෙකක් තුනක් තියාගෙන times gaps එක්ක මම මේකට attend වුණා කවුරු හරි request කරොත් ඒකට proof එකක් හැටියට. Right, Doctor, before moving into the questions from the audience, I would like to just ask some few areas which was highlighted in many times, and I got some WhatsApp messages as well about this earthing electrode. There are sometimes people use rods, sometimes use the earthing plates, and it is sometimes copper and sometimes GI pipes. So how do you simply distinguish them, and what would be the better application when it comes to rods, plates, pipes, and different materials?
Yeah, I think it's a very good question. Most of the people have that the question that doubt as well. So what is the more suitable, or what is the most effective type of earth electrode system? So that now when you look at the earth electrode system, what we are worried about is the earth electrode resistance value. When you look at the earth electrode resistance, that will depend on the geometry of the earth electrode, whether you use the rod or whether you use a plate or strip or the conductor, whatever. So there are standard equations to calculate the earth electrode resistance by using their geometrical shape. So, and the other most important thing is the soil resistivity. So that everything will depend on the soil resistivity. When you look at the soil resistivity, so there can be different soil resistivity value at the site. So that depending on the resistivity value, you have to calculate, or first you have to estimate that what will be the most suitable earth electrode for that particular location, whether it is a rod type or whether it is a plate type or whether it is a mesh type, whatever, you have to do an initial estimation. Unfortunately, due to time limit, I could not show the equations and other things, how to calculate those earth electrode resistance value with the different geometry, but there are certain equations which you can use. But keep in mind, when you look at those equations, again, whether you are using copper or whether you are using GI, it doesn't matter, because when you look at the earth electrode resistance comes from the soil, not the electrode material. So electrode material is matter only for the durability. So that then depending on whether you are using rod, the copper rod or the GI rod, will depend on your durability. So that obviously if you go with the copper rod, so that will be more durable than GI, because if the GI get damaged, that start to corrode, something like that. Other than that, okay, the earth electrode resistance will not depend on the material, but earth electrode resistance depend on the geometry, type of the earth electrode, whether it is a plate, rod, or that you have to decide based on the soil resistivity. There are standard equations so that where you can calculate or you can estimate what is the expected earth electrode resistance value for that particular site, depending on its the resistivity value.
Resistive value of the place where we are installing these conductors, I believe.
Yeah, exactly.
Yeah, and so that most of the time, as you mentioned, that even in sometimes even when we do projects also, we are quite reluctant to connect all these earthings, as you mentioned, that dirty earth or clean earth. So especially when it comes to once you have a HT installation, transformer, say if I have a transformer of 1500 kilowatts kVA, and we have a generator as well. So generally those are from two different suppliers, where generator supply, particularly they demand that I need a separate earth, and the transformer, maybe say it's medium voltage supply. So they also need a separate earthing for the neutral separately. So what's your recommendation when it comes to one single installation with, say, we have a example 1500 kV transformer plus 1000 kV generator? What would be your recommendation?
Yeah. So when you look at that type of things, everything will depend on whether you select TT earthing or TN earthing. So that first you have to look at whether your design is a TT earthing design or TN earthing design. So if it is a TT, so you don't have any other option other than keeping a separate transformer neutral point. What will is your friction space to separate. You need to have two earth electrode. Due to now, for example, if you look at the Colombo area with the restricted the location, if you have a high-rise building where the transformers are also inside the building, sometimes you cannot find out the location to install two separate earth electrode. So in that case, the designer should decide if you have that type of restriction, no point of going for a TT system, then they have to design it as a TN system. If it is a TT, that everything will depend on whether you are choosing TT or TA. If it is TT, you have to maintain the neutral point earthing separately to the separate of the building. But if it is a TN, where you have a restriction of maintaining two separate earth electrode, from the beginning, you have to design it as a TN system. So if you have a dedicated power supply or your own transformer. So if you are decided as a TN system, even for the generator, they cannot demand a separate earth electrode, because you cannot run if it is a TN system, because your protective devices are set for a TN system. So that then if you run it as the TT system or with a separate earth electrode, your protective devices will not detect those faults even during a faulty situation. So that if it is designed as a TT, you have to maintain as a TT. If it is designed as a TN, you have to maintain as a TN all the sources. No matter whether it is a transformer, no matter whether it is a generator, even if you have a solar PV system, all sources you have to maintain as a TN system. So that is equipotential bonding, and all the earth should be connected together.
Yeah, thank you very much. And with the very limited time we have, ladies and gentlemen, we are simply shooting some few questions. And if you have any questions, you can send it through WhatsApp, and we'll compile together and send it to Dr. Asanka and get the responses, and we'll share within the WhatsApp groups. Sanjay, can we give some opportunities to those people who have their hand raised? We have 3 hand raised. And ladies and gentlemen, we will have maximum 15 minutes from here onwards. And Dr. Asanka, I don't think that you wouldn't mind staying 10 minutes.
I'm okay. I can spend, okay.
Thank you very much. Sanjay, shall we give a few hand raised and very
Yeah, I'm
limited
sorry.
number?
Then Shafan, you can ask the question now.
And please make it very briefly. You can use either language, Sinhala or English.
Dr. Sankar, can I ask about the surge protection device for the DC system? We can combine the earth system for DC and AC. Can you clear it?
Yeah, so especially if you have a DC system, especially like a solar PV installations, you have the DC side as well as the AC side. You are not allowed to maintain two separate earthing system. You have to have, it's a mandatory where you have to get it to a, for example, like a inverter location, inverter earth, the DC surge protective earth, AC surge protective earth, everything should be combined together, and then that should connect to the common earthing system. So that it's very clearly mentioned in the, with the diagrams also, that is in the standard. So the how to connect that one. So it's very clear that you cannot maintain two separate earth, as I said. So doesn't matter whether it is a DC, AC, whatever, you have to maintain a equipotential bonding.
Thank you.
Next,
Sanjay,
Chaturanga.
Sanjay, පොඩ්ඩක් අපි පොඩි ටයිම් එකක් ගමු. මේ දැන් ඇත්තටම කට්ටිය ඇටෙන්ඩන්ස් එක මාක් කරපු නිසා කට්ටිය මේකෙන් ස්කිප් කරනවා. කට්ටිය යනවා වගේ පේනවා. Dr. Asanka, මම පොඩ්ඩක් මෙතන අර ස්ටුඩන්ට්ස් ලා කීප දෙනෙක් ඉන්න නිසා there are a lot of students here as well. පොඩි මෙසේජ් එකක් Dr. Asanka දෙන්න පුළුවන් නම් ස්පෙෂලි කියන්නේ මෙතන මම හිතනවා second year third year දම ස්ටුඩන්ට්ස් ලාත් ඉන්නවා. අපිට දැන් ජොබ්ස් වල challenges තියෙනවා. ඊට පස්සේ අපි සිලබස් කවර් වෙලා නැහැ කියලා බලනවා. කියන්නේ අපි self education සමය CPD programs වල තියෙන importance එක Dr. පොඩි ටයිම් එකක් කරන්න ස්පෙෂලි මෙතන ඉන්ඩස්ට්‍රි එක කට්ටියත් ගොඩක් ඉන්නවා. අපේ ස්ටඩීස් කියන සහ CPD වල වැදගත්කම පොඩ්ඩක් අපි ෆයිනල් රිමාර්ක් එකක් කියලා තිබ්බොත් මම හිතනවා විනාඩි දෙක තුනක් ගත්තොත් ඒක පාඩු වෙන්නේ නැති වෙයි කියලා. ඩොක්ටර් සංග.
ඔව් ඇත්තටම අර මම ඉස්සෙල්ලා කිව්වා වගේ මම ඒකම තමයි මේ අර මුලදී ස්ටෑන්ඩඩ් එක මේ සෙක්ටර් එකේ මේ ස්ටෑන්ඩඩ් එකත් අරන් ඔයගොල්ලන්ට පෙන්නුවේ මේ සෙක්ටර් එක ගොඩක් වෙලාවට drastically changing සෙක්ටර් එකක්. අද තියෙන ටෙක්නොලොජි එක නෙමෙයි හෙට තියෙන. ඒක නිසා තමයි මේ දැන් පේනවා ඇති 2018 පබ්ලිෂ් කරපු ස්ටෑන්ඩඩ් එක 2020 දී පළවෙනි රිවිෂන් එක කරා 2022 දී දෙවෙනි රිවිෂන් එක කරා. ඒක නිසා මේවා හැමතිස්සෙම අප්ඩේට් වෙනවා. මේ නිව් ටෙක්නොලොජි එක ඒක නිසා අපිට පුළුවන් තරම් මේ අලුත් ටෙක්නොලොජි එක හඳුනාගෙන ඒවා මොනවද වෙලා තියෙන්නේ ඒවා ගැන ලොකු අයිඩියා එකක් අරගන්න ඕනේ. අපි ඉන්ඩස්ට්‍රි එකේ වැඩ කරනවා නම් තාම පරණ ડોකියුමන්ට් රිෆර් කරගෙන පරණ කන්සෙප්ට් වලට දැන් ඉස්සර ගොඩක් වෙලාවට දැන් මම හයිලයිට් කරපු 3 dimensional earthing කියන එක 1980 ගණන් වලදී ගත්තොත් එහෙම ඒ කාලේ කට්ටිය ප්‍රැක්ටිස් කරේ මේ ඉන්ඩිවිජුවල් earthing කියන එක. නමුත් පහු වෙනකොට ඒගොල්ලෝ අයිඩෙන්ටිෆයි කරගත්තා මේ ඉන්ඩිවිජුවල් earthing එකෙන් ලොකු ප්‍රොබ්ලම්ස් ක්‍රියේට් වෙනවා. ඒක ඉලෙක්ට්‍රොමැග්නටික් කම්පැටිබිලිටි වලට කම්ප්ලයි වෙන්නේ නැහැ. ඒක නිසා අනිවාර්යයෙන්ම අපි මේ ඉක්විපොටෙන්ෂල් බොන්ඩින් කියන එකකට යන්න ඕනේ කියලා. ඒක නිසා තමයි ස්ටෑන්ඩඩ් වලටත් ඒව දැක. එතකොට ඒක නිසා මෙන්න මේ වගේ ඒවා පුළුවන් තරම් අපි දැනුවත් වෙන්න ඕනේ. ඒ දැනුවත් වෙලා මේවා දිගින් දිගටම ඒ කියන්නේ කන්ටිනියු ඒක තමයි මේ කන්ටිනියස් ප්‍රොෆෙෂනල් ඩෙවලොප්මන්ට් වල තියෙන ඇඩ්වාන්ටේජ් එක. ඔයගොල්ලෝ අද ඉගෙන ගත්තොත් ඒක අද ඉගෙන ගත්ත මම ඔය කෝස් එක කරන්න තියෙන්නේ කියන එක නෙමෙයි වෙන්නේ. මොකද මේක හැමදාම අප්ඩේට් වෙනවා. දැන් මම අද ඔයගොල්ලන්ට කීපයක් හයිලයිට් කරා මොනවද මේ ස්ටෑන්ඩඩ් එකේ හයිලයිට් ඒවා very important. ඒව ගැන knowledge එකක් නැත්නම් එහෙම අපි ඉන්ඩස්ට්‍රි එකේ වැඩ කරනකොට ගොඩාක් ප්‍රශ්න එන්න පුළුවන්. ප්‍රශ්න ඇවිල්ලා ඒ වගේ root cause එක හොයනකොට තමයි දැනගන්නේ අපි මේක කළා නෑනේ. මේක නිසානේ අපිට වැරදිලා තියෙන්නේ. ඒක දැනගන්න. ඒක නිසා මේවා ෆලෝ කරන එක හරිම ඉම්පෝර්ටන්ට්. ඔයගොල්ලන්ට in depth knowledge එකක් ඇත්තටම අනිත් එක තමයි මේක ගොඩක් වෙලාවට superficial මම කරන ලොකුම ඉල්ලීම තමයි superficial level එකේ විතරක් just වචනයක් දෙකක් කියවලා නැත්නම් කාගෙන් හරි අහලා ඒක ප්‍රැක්ටිස් කරන්න යන්න එපා. ඒක ගැන හොඳට ස්ටඩි කරන්න. මේ ස්ටඩි කළා ඒක තමන්ම ස්ටඩි කරන්න හොඳට ඒක ඩීටේල් කරන්න. එහෙම නැති වුණොත් අර කාගෙන් හරි අර මාකටිං කත්වි කරනවා වගේ කාගෙන් හරි වචනයක් දෙකක් හොයාගෙන මේ වචන දෙක අනුව ප්‍රැක්ටිස් කරන්න ගියොත් එහෙම අපිට ලොකු ප්‍රශ්න වලට මුහුණ දෙන්න පුළුවන්. ගොඩක් වෙලාවට ඒක වෙනවා ඉන්ඩස්ට්‍රි එකේ. ඔය එහෙම මෙහෙන් කැලලක් දෙකක් අල්ලගෙන ඒක මෙතනදී අර ඉන්ස්ටොලේෂන් එකේ මෙහෙම තිබ්බේ අපි ඒකම මේකට කරනවා කියලාත් කරගෙන යනවා. එහෙම කරන්න බෑ මේ සෙක්ටර් එකේ. ඒ නිසා මේ සෙක්ටර් එක හොඳට ස්ටඩි කරලා ඒකේ හොඳ තියරි ටික හොඳට දැනගෙන ඒක කොහොමද ප්‍රැක්ටිකලි ඇප්ලයි කරන්න කියන එක දැනගෙන ඒ විදිහට යන්න කියන එක තමයි මගේ මූලික ඉල්ලීම හැමෝටම.
Thank you very much. And especially with my experience, especially when it comes to the foreign projects, when you go out from Sri Lanka, I think there are a lot of challenges right now, especially Indians and other countries. They are studying to the best of their abilities and they are not simply glancing, as Dr. highlighted, and they go very deep. So we have to be very thorough with our knowledge. Sanjay will quickly go with our hand raise. We can go maximum of 5 hand raise, Sanjay. We'll go first in services.
Chaturanga Kannanga, yeah. Chaturanga, you can ask a question.
Yeah. Can you hear me, right?
Yeah, clearly.
Yes, one of our friends, I think, Chaturanga.
Right. Yeah, just Dr. Asanka, there are a couple of questions I want to raise. One is about you have shown the table 53.1 where you have shown the earth resistance. So in that table, is that refers to the earth loop resistance, the total earth?
Yeah, basically it talks about the loop impedance.
Loop
So that when you
resistance
look
or
at the
earth
standard,
electrode
yeah,
resistance?
yeah. So, but when you look at the earth electrode resistance and the loop impedance, when you look at overall, so that that's almost if you can maintain below that one the loop, that means anyway your earth electrode resistance is below that value. So that is the idea. That's why they are highlighting the loop impedance in that the location.
So we are it's like we are assuming the loop resistance is sort of equal to the earth
Yeah,
electrode
because
resistance.
yeah, normally not equal. So that what will happen is especially like if we have structural earthing and the multiple earthing, so that it's very difficult to measure the earth electrode resistance correctly. So that in that case, especially in the TT system, what we can do is we can measure the loop impedance, and if the loop impedance is the within the range within that value, that means loop impedance include your earth electrode resistance as well. So that basically fulfill our requirement.
Right. And one more thing, Dr. Sang, it's regarding the protective bonding for the doors and windows. For other, when you're supplying for a particular equipment, we can consider the neutral cable size to define the potential bonding. But for the when you're connecting like pipes, doors, and windows, how can we size the protective bonding? Cable size.
The standard, as I said, the standard gives us what is the requirement for the protective bonding. So that those are we call as the protective bonding. So that the requirement is basically you have to look at that particular the installation. Now where you are going to connect your doors and windows, what location, so that what distribution board or what equipotential bonding point you are connecting. So that then you have to look at what is your the neutral conductor for that particular location, and you can connect them together. Now mostly what we do is in practice, if you look at like a high-rise building and many other buildings, you use a structural earthing directly and connect them. For example, if you have a the floor slab, so that you can connect these doors and windows directly to the structural earthing by using a conductor or by using a copper tape or even by connecting them directly to a rebar, so that that will work as a your structural earthing. So that type of now normally when you look at most of the high rises, what we are practicing is so that those doors and windows we connect to the structural rebar, so that then you don't want to worry anything, you don't want to run separate conductor, so that that will act as a equipotentially bonded the network.
Right. So the cable size when you are connecting maybe a window to a rebar, that size of the cable, how can
that will depend on your supply neutral conductor size. So as I said in the table gives that okay, the less than 35 millimeters square, the more than 35 to 50 millimeters square, minimum requirements are given, so that you can use whatever more than that minimum cross section.
Right. Okay. Right. Thank you, sir.
Sunny, we'll move to this next, please.
Jan, you can ask question.
Guyana, isn't it?
Jayan Mendes.
Jayan.
Yeah, we will go to Sampath. Sampath?
For the meantime, doctor, there's a chat box question as well. How we can size the equipotential bonding conductor when we have several earth terminals in buildings as per 544. That's 1.1. That generally we.
Sorry, I'm okay.
Half size of the
That doesn't have.
conductor. Half size of the conductor for the bonding budget. That thumb rule which people generally use. Can you make a small comment on that, please?
So the protective conductor, are you asking about the protective conductor or the bonding?
Yeah, it's mentioned as equipotential bonding conductor, but I don't think that is half of the conductor. It's generally the protective.
Yeah, it's not the half of the conductor. So we consider the half of the conductor for the protective conductor. Protective conductor. So that is where when you are not calculating your fault currents, so that you cannot use the adiabatic equation. So that in that case you can use that half a size of the phase conductor as your requirement. It's not just a half because up to 16 millimeter squared you have to use the same size, and more than the 16 millimeter, so you can go with the half size of the phase conductor as your PE conductor.
Hello, sir.
Yes, please go ahead.
Yeah, go ahead.
Sir, can you explain me briefly how to do a risk assessment? And my second question is, when we are laying some copper cable through a rebars, then is there a long-term problem by galvanic corrosion?
Can you repeat the second question again?
When we are placing some copper cable in high-rise building through a rebars, then there is a problem. If there is a problem in long-term basis by damaging for the copper cable or for the steels by galvanic corrosion.
Yeah, the first question, okay, risk assessment. Okay, there are certain white papers are there how to do the risk assessment of this earth fault, and what type of the requirements are there. Basically separates the subject area where you have. There are even computer softwares are also there to do the risk assessment. What type of risk is there in that particular site on arc fault protection. The earth fault protection or earth faults, those type of things you can look at depending on number of points and the possibilities, all of them. Okay, there is a standard way of assessing it, and it's a separate subject which I cannot explain it here. But if you go to internet and just search it, you can find out a lot of the guidelines how to do that risk assessment. And the second question is, when you are connecting obviously copper to the iron, so there will be a galvanized corrosion. But the main advantage in within the concrete is because you are not providing the oxygen. So if you are not providing that oxygen, so there will be very less possibility of having the corrosion. But for the safety, what you can do is when you are connecting them, you can connect using the bimetallic connection. So that there are bimetallic connectors, so that just rather than connecting them directly copper to a steel, what you can do is you can connect them using a bimetallic connection, so that in between those two, so that will avoid or reduce or prevent the corrosion.
Thank you, Sanjay. We'll go for two more questions, please. Sanjay, if we have any more hand raised, do we have any more hand raised?
Yeah,
We have a lot of hand raised.
Nuwan, you can ask question. Nuwan Perra.
Nuwan is the one who asked the question.
Should be done.
Sampath. Anju, right? Anuji, right? Anuji, you can ask question.
Good evening, sir. මගේ ප්‍රශ්නය දැන් අපි ෆවුන්ඩේෂන් earth එක යූස් කරලා තියෙනවා නම් අපි හිතමු high rise building එකක් හරි footprint එක ඉතා විශාල irregular shape එකක මම යූස් කරන්න යනවා අර 3 rod method එක earth resistance එක මයින් කියලා. එතකොට මේ කොච්චර කොච්චරක් ඈතින්ද අර earth voltage probe එකයි current probe එකයි ගහන්නේ කියන එක පොඩි ගැටලුවක් තියෙනවා සර්. ඒක depend වෙන්නේ දැන් අපි ඉගෙන ගත්තේ නම් අර earth rod එකේ dimension එක වගේ පස් ගුණයක් ඒ වගේ ඈති කියලා මට මතක. දැන් මේ වගේ එක කොහොමද කොච්චර ඈතින්ද ඒක මම ප්ලේස් කරන්න ඕනේ?
earth electrode measurement එක කරනකොට ගොඩක් වෙලාවට අපි ඔය ගත්තතින් එහෙම earth electrode resistance එක matter වෙන්නේ TT එකේදී විතරයි. ඔය අනිත් ගොඩක් වෙලාවට තියෙන myths එකක් තමයි ඔය අපි හැමතැනම earth electrode resistance එක measure කරන්න ඕනේ කියන එක. මොකෝ earth electrode resistance එක measure කරන්න ඕනේ අපි earth එකට current එකක් යවනවනම්. TN එකේදී අපේ තියෙන්නේ කෙලින්ම metallic connection එකක්. TN එකේදී අපේ earth electrode resistance එක matter එකක් නෙමෙයි. නමුත් අපි measure කරනවා මේ දෙකේදීම earth electrode resistance එක මේ lightning protection එකේදී. මොකද lightning protection එකේදී අපි කියලා තියෙනවා less than 10 ohms maintain කරන්න කියලා. ඒතකොට ඒකෙදී TT ද TN ද කියන එක matter එකක් නැහැ. අපි maintain කරන්න ඕනේ less than 10 ohms. ඒතකොට මේක measure කරනකොට අපි පුළුවන් තරම් කරන්න ඕනේ මේ තියෙන බිල්ඩින් එකේ හරි ඒ කම්ප්ලෙක්ස් earth electrode එකෙන් එළියට යන්න ඕනේ. ඒතර අපි 3 point fall of potential method එක use කරනවා නම් ඒකෙදි අපි බලන්න ඕනේ අපේ ගොඩක් වෙලාවට the probes වලට මේගොල්ලෝ manufacturer ම යාට drive කරන්න පුළුවන් current එක check කරලා එයාගේ leads ටිකක් දෙනවා. ඒතර මේ කේබල් වල distance එක 20 meter ඒ වගේ distance එකක් දෙනවා. අපි පුළුවන් තරම් ඒක පාවිච්චි කරන්න ඕනේ. නමුත් එකම එක කරන්න ඕනේ middle probe එක අපි පොඩ්ඩක් plus or minus 10% දෙපැත්තට vary කරලා measurement එක අරන් බලන්න ඕනේ අපිට එන්නේ measurement එක same value එකද කියලා. ඒ කියන්නේ plus or minus 10% vary කරාම midpoint එක still මගේ measurement එක හරිනම් මට දෙන්න ඕනේ same result එක. same අපිට එහෙම result එන්නේ නැහැ කියන්නේ මගේ measurement එක එහෙමනම් මගේ අර අපි red cable එක ගත්තදින් එහෙම නැත්තම් අර probe එක මම ටිකක් එහෙම බැරි ප්‍රශ්නකුත් එන්න පුළුවන්. ඒක නිසා ඒ වගේ තැනක් measure කරනකොට සාමාන්‍යයෙන් හොඳ අර අපි පාවිච්චි පොඩි earth electrode meters හරියන්නේ නැහැ. ඒ වගේ තැනකට ඔය large complex එක earth electrode measure කරනවා නම් අන්ට එකෙන් පුළුවන් තරම් ඈත අපි අර the distance probe එක පුළුවන් තරම් ඈතට ඒකමයි තියෙන්නේ. නමුත් අපි දුර වැඩි වෙන්න අපි මීටරේ capacity එක වැඩි වෙනවා. Modification එකයි අපි වැඩි කරන total distance එකෙන් කරලා බලන්න ඕනේ මට එන reading එක same reading එකද. මට reading එනවා නම් මම vary කරනවා vary කරනකොට ඒ කියන්නේ මගේ අර distance එකේ තියෙන probe එක තව ටිකක් add කරන්න ඕනේ කියන්නේ. එහෙම add කර යන්න ඕනේ. මගේ අර mid point එකේ reading එක plus or minus 10% එක same value එක එනකම්. Clear නේද?
Thank you very much sir.
Thank you, Sanjay. We'll move into the next hand raise, please. We have 3 more. We'll quickly finish these 3. Philip Pereira, Dundayavansa, and Roger Talbot.
Yeah, Mr. Dayavansa, you can raise the question.
Mr. Dayavansa, you are muted. I think they can unmute themselves, right? Dr. Asanga, can you hear us? I think your video is stuck. All right, okay.
If not, we will go to Roger.
Hello.
Yes, Roger, please go ahead.
Dr. Asanga, some of the designers are specifying 1.5 millimeter squared earth cable for the final circuit, whereas the standard, it says in somewhere, the minimum earth cable size should be 2.5 mm squared. What is your opinion about this?
Yeah, circuit protective conductors, if your cable sometimes ring specify maintain.
Doctor, shall we switch off your video, please, if you wouldn't mind? Then I think we have a small bandwidth issue.
But
Yeah,
your
I'm-
equipotential bonding and the bonding conductor should be minimum.
I cannot hear also.
Now, how is
Yes.
that?
Now it's okay. I think once the video is switched off, can you sir, can you please start from the beginning for the question? Now it sounds
Yeah,
okay.
so that even for the ring circuit and the Shakata circuit, if you look at standard, it's to go something like a 1.5 millimeter square minimum cross section area as a circuit protective conductor. So that is allowed. But for the equipotential bonding and the main the bonding conductor, definitely you need to have the 2.5 as a minimum requirement. So that main cable which are coming from your, let's say, the final distribution board to the other location, other distribution board, minimum is 2.5. So that you cannot reduce it more than that. So that everything will depend on your the earth fault current. So that depending on whether it is a TT or TN, you have to evaluate that what will be the earth fault current in that particular circuit, and based on that you have to decide the requirement. So that for final circuits like a socket outlet, so the even if you refer the diagram, the diagram itself use the 1.5 millimeter squared as well for the circuit protective conductor.
Okay, thank you, sir. And Sanjay will go for the final hand raise. Do we have any more? I think that's also. Sanjay, do we have any more hand raised?
Mr. Nalin, we have completed.
All right. Okay. Thank you. Thank you very much, and thank you, Doctor. If there are a lot of messages came through WhatsApp groups and even the chat box also. So if you can spend some time, we will compile all those issues, all those questions, and we'll send you one email. And we highly appreciate if you can just send the reply so that we have some WhatsApp groups. We can share those answers with the whole audience.
Yeah, sure. Yeah, definitely I can do it. No
Thank
problem.
you. Thank you.
And even my contact informations are also here, so that if anybody wants to contact me personally, okay, I'm free to support you, so that you can contact me. So if you have any other additional the questions or anything, so you are free to contact me directly.
Thank you very much. And this is it's greatly appreciated, and it's a pleasure with you having these questions. And ladies and gentlemen, if you have any issue, what we recommend is just drop him a WhatsApp message, or you can send an official email. And most importantly, this whole YouTube, the session is recorded and through YouTube, and we will share the whole YouTube session. So what we recommend again to just share with everybody who needs the knowledge, who seeks for the experience and exposure. So that is one of a national service which we believe. Doctor, for the final remarks, do you have anything to conclude? So we are almost about to close the session.
No, I think that's fine, Nalin.
All right. Okay. Thank you. Thank you very much. And ladies and gentlemen, thank you very much. You all have been a great audience, and especially I would like to thank Dr. Asanka Rodrigo from Department of Electrical Engineering from University of Moratuwa. And as I mentioned earlier, Dr. Asanka is a different person, which I recommend, and I personally believe that one of the best resource person in terms of design, installation, and theoretical knowledge. One of a giant in Sri Lanka and in the world itself. He's one of a great resource person. And thank you, Doctor, for being with us in this within your busy schedules, especially on a Sunday evening. Ladies and gentlemen, thank you very much for the first day of 4-day sessions of CPD programs. We are almost about to conclude the session, and we have a lot of people behind the screen, especially Sanjay and our Master, as well as Danushka from Magnus Academy, who helped to make this event a success. And please join and continue for next 3 days as well. We have another electrical session plus 2 more ELV sessions. And we believe that this knowledge sharing would definitely help all these professionals to share their knowledge, and don't be selfish to share these videos with anybody. If especially there are a lot of students, if you could see, there are a lot of index numbers. I believe that there are a lot of undergraduates here. So if you think that these areas are not covered in your subject, and this is not this may not be an excuse in the future, because this knowledge is all available through different materials. So please go through and study, because the future is so seriously challenging. So you cannot simply say we were not taught those areas. So you have to seek, find, because this now is all knowledge-based studies. This is not a conventional studies right now. With that remark, ladies and gentlemen, thank you very much. You were a great audience, and let's meet in the next Sunday evening, same time, through Zoom. We will share all these details. Zoom links, it's the same, and we will share the recordings as well in the WhatsApp groups. Thank you very much. Have a pleasant evening. Good night.
Good night. Good night, everybody.
Thank you.